we did a lot of TypeScript challenges and always trying to. We were doing this clash of code and trying to see if all problems could be solved with types only. And I was thinking, instead of trying to take each problem and try to solve it, we could do one thing that will solve all problems at once. And I always remember this quote, which is, all Turing-complete languages are equally powerful. So if we can implement a Turing-complete language using TypeScript only, then we know that we can solve all problems, because given infinite amount of memory and computing capabilities, which we don't have with TypeScript, we can compute anything that any other programming language can compute.
Oh God, another one of these type-only experiments. These are always so crazy. What do you have in store today?
These are so addictive. I know that some people like it. And what triggered me to do this is that I was looking at the TypeScript 4.5 changelog, and they increase a limit in terms of how many recursive calls you can do. So for instance, I don't know if you remember, but we implemented inc and decrement numbers. And then from there, we did subtraction, multiplications, and so on. And here the limit has been dramatically increased. So for instance, here I can increment 900, I can increment 999. And so this limit has been increased dramatically. Last time we played with this, we couldn't go so far. So what we did is that we implemented increment and decrement. So this is from last time. It's all based on count2, which is computing a tuple based on a number. So to increment, we simply add one element to the array and return the length. And to decrement, we take the tail essentially, and we return the length of the tail. And and what we did last time is that from these two primitives, we try to implement a bunch of operations. What we're going to do this time is that we're going to implement a Turing complete language here, namely Brainf, because it's extremely simple to implement. And then we know that if we have this Turing complete language, we can then compute anything. We can compute subtraction, additions, reverse word. We can do anything that you could do in JavaScript.
Right. So this increment, decrement stuff that you just showed, this is just the super simple stuff. Sure, it might not be the easiest way to increment a number, but this is not the first video like this that we are doing, and this is the base case. So how did you one-up this one?
Are you familiar with the Brainf language?
Brainf? Well,
Swiss made in Switzerland.
Made in Switzerland.
Swiss quality.
That's crazy. We should maybe think about interviewing that person. Yeah, I know that it's like a really esoteric programming language that it's really hard to write and use like just garbage, like code that looks like garbage but actually is logical. But yeah, maybe you can quickly explain what Brainf is all about.
Yes. So very simple. You have some input, you have some memory, and you have an output. And the program can contain 8 commands. So here you move the pointer forward in memory. Here you move it backward. You can increment the value of the pointer, the value in memory. You can decrement the value in memory. You can output the value that is in memory. You put it into the output. You can get the value of the input, and you can do a while loop. Okay,
so 8 commands, but you can build anything on top of it.
Anything. So all Turing complete languages are equally powerful. So you can implement React in Brainf and everything. Don't get me started on this. So let's implement the Brainf compiler with types only. I think you're going to be surprised how easy it can be done. So before we implement the compiler, we need one primitive, is that we're going to have some memory, so an array of numbers, which is the memory, and we're going to need to be able to write into the memory. So we need something that looks like this. We need, so type equals write, and so we have some memory, so which is an array of numbers. We need an index, so which is a number, and we need a value which is also a number. And so we need to write the value in the array. So we can, in memory at index, no wait. So we can write value at memory.index. And so here we need to copy everything that is before the array and everything after that is after. So here we can do before. So we do a subsequence of the memory at index, so everything that is before. I need to spread it. And here we need to write after everything that is after the index. So that's how we can write a value into memory.
All right, William, really quick. How do you even come up with the stuff? That's crazy.
I don't know. I just find it so addictive, and that's what holidays are for, right? You get some time off, and you can do some crazy investigations. I don't know why I find this so addictive. It's so useless, kind of, but it's just so much fun.
Yeah, seems like a really strange addiction. You already lost me there with this write type, but you seem in the flow, so.
No, so we're gonna need to increment and decrement values in an array of memory. So we need a way to write into an array so to do essentially the operation. How do you do it in a regular array? Like I equals 3, for instance.
So this is like the malloc function.
Yes.
In C. Okay.
So how do you do this operation in types only? And you clone the array. You put the value and you put everything that is before index and everything. But wait. Okay, that's actually a great question. Because that's my way of doing it. And I've seen some other people have different approach to this problem, which I'm going to show you after and which I find super interesting. So this is also why these things are so addicted, because you can tackle the problem in different ways. But that's how I'm approaching the problem. There is another way to do it, which I'm going to show you after, which I found online. And yeah, you will tell me what you think after.
All right. So it seems like we are missing some before
Yes.
and after types.
So let's write before. So we have memory, extends number, and index. So how do we do before? So we're going to clone. So we're going to use the same recursive technique than here. We're going to clone the elements one by one, return so we know the array has a length index. So as soon as the length of the state is index, we return it and so on. So this one we've done it many times. So we have a state which defaults to an empty array, and it extends an array of numbers. If the length of the state equals index, we return the state. If not, we do a recursive call. So let me actually here Copilot I think is giving me the right suggestion. So we increment by 1, which is the value of memory index. And let me try it maybe. So we do before, and we have 0, 1, 2, 3, 4, 5 at index 2. So it should return 0, 1. No. So it returns memory index. Zero, two, two. So if I do 1, So it's not index, it's the value at length at S. So you see Copilot can be dangerous sometimes. You take the suggestions for granted, but
Yeah, I always thought TypeScript would warn you if you made an error and it would be completely obvious. But man, it's actually very complicated.
so the problem here is that we're doing meta TypeScript. So we don't have, when you do meta TypeScript or type only TypeScript, you don't have the safety and mechanisms that you have when you write JavaScript and you use TypeScript.
Yeah, the question is who's going to type the meta TypeScript? But
yes,
I mean,
exactly. Who's going to type the meta TypeScript? Exactly. Well said.
Let's not touch on this right now.
But we're going to touch on it later.
And I can already see all the YouTube commenters saying, why do you copy the whole array? And we should just remind them that this is all types.
Only.
So if you compile it, it's going to have zero runtime effect. It will be super fast.
Exactly.
So don't forget that.
Yes. And you're going to see while implementing the Brainf compiler, there is a point in time where you need to do a cast on a type. So a cast on a cast because, anyways. So we have
really deep into there.
So we have the before and to do the after. So it's very similar to increment and decrement actually. We are going to do so infer. So we have memory. So we're going to remove the state here. So we have if memory extends, and we're going to infer the before. So memory index, the value. So we can do infer value and infer the rest. So if this works, we can return the rest. If not, we return never. And we can try
so
it.
the after type is dependent on the before type.
Yes.
Okay.
So we infer the whole array and we return the value. So here it seems to work nicely. So now we have a nice way to write into memory. So now that we have this, we can write a brainfuck compiler. So let's write a brainfuck compiler. Am I allowed to say fuck on YouTube? I guess we'll find out. I guess so. I mean, it's a scientific word here. I don't know.
You will probably not earn any money on this video,
Okay.
but I mean, if you code a brainfuck compiler, you probably don't care about the money anyways.
No.
So
that's all
just
good.
fuck it. Let's go. I mean, now we've already said it.
Yes. So we have an input, which is going to be the program. And maybe as the first command, we're going to read, so comma, so we're going to read the input and output it. Very simple.
Okay, so that is a sample brainfuck program.
Yes.
Comma dot. What would that be?
So
in
comma.
In terms that we understand.
Yes, here we read the input char and we output it.
Okay, you read an input and write it into the
output.
To a type in this case.
So here we are not even dealing with memory yet or anything, but just a very simple one. And input, maybe I put 42. I don't know, any input. And so we're gonna write brainfuck program input. And so we have 8 commands to implement, and here we are using 2. So we're gonna write brainfuck. So we have program which extends a string, and we have an input which extends an array of number. And maybe we have an input of, maybe I'm getting ahead of myself, but the input has a certain length, so we need a pointer on the input. So input pointer is a number. So if I do comma dot, it's going to output the 2 values. So I need to increment the pointer on the input so I know where to... Okay, so we gonna infer the command from the program. So we do if program extends comma, and then we infer the rest. We're gonna execute the command, so I'm gonna have a brainfuck. If not, we output. So we have the output where the default value, so extends the string and default value is empty string. Now, so if it's a comma, we read the input, so put the input in memory, increment the input pointer. Yeah, that's all we need to do. So program is the rest of the program. So we only the remaining commands needs to be executed in the next call. The input never changes. We increment the input pointer. So we have already a function for this. And the output is unchanged. We don't do anything. And we need the memory. So we have memory, which extends numbers. We can put some default value here. Maybe let me put it here. I don't know. We can choose the size, any size we want. Oops. Yeah. And we need also a pointer on the memory because we're going to need to move it around. So I'm going to call it memory pointer. So we have memory. So here we're going to need to write the memory. And the memory pointer is unchanged. So here we use write. And then, so we write on memory at index memory pointer the value of the input. So input, and we have the input pointer. Does it kind of make sense?
Oof, I hope it makes sense because I'm probably unable to troubleshoot with this.
Okay.
But if it works, then we have 1 out of the 8 operands of brainfuck, which is pretty good.
So it's complaining. Program is already declared. Yeah, I mean, I guess that's fine. Yeah, let's try to troubleshoot. Okay, here, so this one is interesting because it says increment of input pointer does not satisfy the constraint number.
That's indeed weird because it is a number, right?
Because we are on the meta type. So how do you cast at the meta level?
Okay, so it's not as number.
No, so one way to do it would be to do extends number, then you return the value. If not, never. And you see it disappeared. Same here for write, which it says it's not of type array of number. You see and number. The problem is that, so I can do the same here, extends number, never. The problem here is that I'm afraid that the recursive call here gets done twice, right? So we got rid of the type errors, but I think we lowered, or we
can create less complex programs now.
Yes.
But, I mean, you're implying that it's expensive to run when it will compile down anyway. So don't worry.
So, okay, now we wrote into memory, but we need to output. So you see here the output is empty, right?
Okay, so far
but for now I'm going to remove, because I just don't like that we have to compute it twice every time. So I'm going to remove it like this. But now we have one command, and now we need to do the second one. So I'm going to copy this, put it here. And so if we have the dot command, so the input pointer here stays the same, memory stays the same. We just add to the output the value of memory pointer. So we have output, and we concat memory If not, we output. Yeah. So this is the expected result, right?
Sick. I mean, it's if somebody just glances at it, they will have no idea what is going on here. But the three bottom lines, it's just sick. Okay. I'm curious to see how you proceed.
So let's keep going. So here we have commands to move the pointer in memory. And so you see like here GoPilot is suggesting some program. And then we can increment the value of the pointer. We can decrement. Yeah, you can do a bunch of things. So let's do, what should we do? Plus plus, so here you have 3. And you output the thing.
Man, when I woke up today, I knew it was going to be a great day, but I never expected to learn Brainf. And yeah, it all makes sense now.
Yeah, I love the brain.
It seems just like a concept that seems funny, but now it actually makes sense.
Yeah, first I was like, what the fuck is this? And now I kind of love it, actually. And you see, you can implement some fun operations with it, and it's pretty cool.
Mm-hmm. We are hyping it up, and I think it could become a 2022 trend if it can be done in TypeScript types.
So if we have the plus, we write in memory. We increment the value. So we wait a second. So in memory at index, we increment the value. So we increment memory at memory pointer. It doesn't look good. Plus. Oh, and here I need to, the output isn't changed. That's why I think, yeah. So we did 3.
Okay, makes sense.
And so if we do minus, here we would have
3 and then print it. Okay,
yes.
that actually makes sense.
Let's do this one. So we have minus. So here it's the same, but with decrement. So I think here we should have 1 as a result. That works. Now we can move into memories. So if I do plus plus dot, move to the next one, do plus plus. So what is the output of this program?
Okay, so remind me again, the bigger than sign
moves by 1 in memory, the address, the pointer in memory address. So you have it here.
Okay, so going back to the code, the first character will move into index 1 of the memory, increase that by 3, print it, then goes to the next slot, increase it twice, so it becomes 2, and print it. So the output should be 32?
Yes. And if I do this, just to test, and I do -1, 31.
Seems legit.
No, wait.
No, 21.
Yes.
22.
Yes.
22. Something like that.
Yes. Let's do it. So here we simply increment, so memory is unchanged. And we simply increment the memory pointer. Okay. And we need to do the same with, if this works, we have implemented 6 out of the 8 commands.
Almost there.
Almost there. Let's have a look. 32. No.
So.
Yeah, that's correct. So because here we output, so even if we decrement the values, so here it should display 2. Yes. And then we go to the next value and we print it, which could be a 3, a 2 also. Big. Yeah. Yeah.
Fair enough. 22.
22. So,
well done.
Okay, so there is only 2 commands left. These 2 here.
A while loop. Oh God. Now it's gonna be next level again.
No, super easy. Barely an inconvenience.
All right.
So
not for William Candelian.
yeah, let's do it. Wait, so let me copy this one. But we're gonna need a new parameter in our generic. So we infer the subroutine here. So because you can only use this one with a closing, right? It's a loop. So we have a subroutine here. And we have the rest. And so what we need to check here, you see it's a while. So we need to check if, we need to check if the value at memory, so let me remove the decrement here. We need to check if the value at memory is 0. So if memory at memory pointer extends 0, we go back to rest directly because we don't execute what's inside. We skip the loop. If not, we need to execute this whole subroutine, which is here. Yeah, that looks correct. Let me remove.
Like
sorry.
Subroutine is not yet defined.
Infer, yeah, sorry.
Okay.
Oops, sorry. So that looks good, but we need to do one more thing now, because when we reach now this command, we need to go back here. And so I need to remember where I was here. So this is where we add a new parameter, which I'm going to call stack. I mean, even though here it's always, is it always flat? Where we can go back to where we were. So here, yeah, I'm going to simply pass program as an extra parameter. And so I'm going to add a new parameter here, which is called stack. And it's a string, and the default value is empty, but we need to pass it along for each command. If not, we're going to run into troubles. So let me do it here, here. And here, no, it's okay. So, okay, and now if we encounter this part, this command, we go back, so we simply re-execute whatever is in stack. And here's the stack. We empty this one. So let's see if it works. So we have a 3, and we can decrement it until it's 0. And if we print it, it should say 0.
Wow.
I mean, I can even remove this one. Yeah. So let's try our compiler. What if I want to add 32 plus 7 in Brainfuck? Do you know how to do it?
I use a loop to increment 3 times.
Exactly. I mean, 3 times. So we're going to write these 2 numbers in memory. So I'm going to write input the first, get the first one in memory, move, and write the second one. So now we have our 2 numbers in memory. And we're going to, while this one is greater than 0, we're going to increment the other. Once the loop ends, we display the other value, right? So we do a loop. We decrement this one. We go to the next cell and add 1, because we remove 1, add 1 to the other. Go back to the cell that needs to be decremented. And once we're done, we go to the next cell and display the result. So this should be 49. No. Wait, so we move the cell. We increment. That looks correct, doesn't it? Or
I'm only
we
a bit lost.
Sorry, we need to go back. So here we moved cell, put the 7 value. We need to go back to 32 here. Yes, 49.
49. Well done, William. I think after this video, you can skip the coding interview at Google and go straight to a senior engineer. But no, I mean, you have successfully fucked my brain.
But you mentioned something. So you see how now we can solve any problems with it. It's equally powerful as any other programming language. But you did mention something super interesting about the write into memory, which you found super tricky. And actually, that's how I was thinking about it. But I saw someone who had a very different approach to this problem. And so first, there is a npm package, a GitHub repository that implements a Brainf compiler in type only, which has a completely different approach. And I looked, so this playground code is different, but I used the same ideas that they used in the GitHub repo. And here, instead of using numbers, they use characters. And so the way they do increment is that they simply get so they have a value for increment. So they have a table for increments and a table for decrements. No, they have a table of characters and a table for they are decrements. So you can simply access for index 1 the next value, but here we are dealing with strings, which is interesting, but of course you're limited to 255 or to whatever you... But then another interesting idea that I found in this code base is that the way to do the write into memory. So the memory is a structure where you have the left, the head, and the right part. And then you see you do a move left, move right using tail and head. And instead of doing the crazy copy of everything, you simply move things around like this. And it works pretty well. So memory is just left part, head, right part. And I re-implemented the Brainf compiler using this method. And you see here we reversed. So we had the hello world input. So here I have the memory. So the left part is empty. The head is the H. The rest is the hello world. And this Brainf compiler just reverses the string. And it seems to work pretty well.
Wow. So it's not just for adding numbers. It's a real programming language.
As equally as powerful as any other program. No, but it's interesting. You see, you can approach these problems differently. So that's nice. But now that we implemented Turing complete language, what are other TypeScript challenges are there for us? Because now we can do anything.
I mean, this is already beyond my imagination. I'd say people should leave crazy 2022 vision TypeScript challenges in the comments.
Yes, absolutely.
All right. Do it.